Hi all, my name is Catherine, Assistant Professor from the Department of AAML, SNS College of Technology, Coimbatore. Today in our lecture series, we shall see about the public key crypto systems. So public key crypto system is nothing but the asymmetric algorithms. It is a method of asymmetric encryption and decryption. So here the asymmetric algorithms rely on one key for encryption and a different key, but a related key for decryption. Earlier we have seen about symmetric encryptions where the encryption and the decryption relies upon the same key. So here the plain text, we have certain terms such as whatever we had in the symmetric encryption systems. Plain text, this is the readable message or data that is fed into the algorithm as input. And encryption algorithm, the encryption algorithm performs various transformations on the plain text, public and private keys. This is a pair of keys that have been selected so that if one is used for encryption, the other is used for decryption. Basically, the sender and the receiver, both of them will be generating two keys, private keys and public keys. So they can decide upon which key should be used for encryption and which key should be used for the decryption. For example, if you are taking the private key for encryption, the corresponding public key only should be used for the decryption. So ciphertext is nothing but a scrambled message produced as output. Decryption algorithm, this algorithm accepts the ciphertext and the matching key and produces the original plain text. So here, as I told you earlier, each user generates a pair of keys to be used for the encryption and decryption of messages, and each user places one of the keys in the public register or other accessible file. One of the keys is nothing but the public keys will be kept in the public accessible file. This is the public key. The companion key is called the private key. So as I told you, every user will have two keys, private key as well as the public keys, and they will keep their public key in the public register for everyone's access. All participants have access to this public keys, and private keys are generated locally by each participant and therefore never be distributed. Only that user will be having access to his or her private keys. So this picture depicts about the public key crypto system. So here the sender is the Bob and the receiver is the Alice. So what the sender takes a plain text, and whatever she is doing is, whatever the Bob is doing is, he has a Bob's public keyring. In this public keyring, he'll be having all his friends public keys. He'll be taking all these friends public key from the public key register, and he'll be having his own public key, just like how you have your friends phone numbers, right? It is available who with your friends has, if your friend has provided his phone number with his local friends or anybody who is having access to his phone number can make a call to him. Just like that, Bob has a public keyring from which he has taken from the directory, he has taken few of his friends public key and he has stored in his public keyring. So now he wants to send a message to Alice. So what he does is he takes Alice public key from this public key ring and he is encrypting the message X. So when you encrypt a message, obviously you will get a ciphertext Y. So ciphertext Y, how did you get? With the encryption of the Alice public key and the plain text. So this public key, this encrypted message goes to the ciphertext, goes to the receiving side, that is the Alice. So now Alice receives a message. So as I told you earlier, if you are encrypting with the public key of a corresponding person, that corresponding private key only you should, the corresponding key only you should decrypt. If you are encrypting with Alice public key, you have to decrypt with Alice private key. If you are encrypting with Bob's private key, you have to decrypt with Bob's public key only. So you always remember the corresponding key should be only used for encryption and decryption. So now the message reaches Alice. What she does, so she sees the message is being encrypted using her public key. So when she receives the message, so obviously she has to decrypt the message by making use of her private key. So private key will be available to Alice herself. So she will decrypt making use of her private key, that is PRAS, Alice private key, and the ciphertext will be decrypted. So you get the output as the plain text. So this is what happens in this public key crypto systems. So now you have a brief understanding of what is public key crypto systems. Here it is nothing but asymmetric encryption. Earlier we saw the symmetric encryption. In symmetric encryption, what will happen? We'll have just K. The same K will be Alice will be having, and she will decrypt that message. So in order to make it more secure, and more difficult for the cryptanalyst to crack the messages, they have come with this public key crypto systems, which has the sender and the receiver will be generating two keys, private keys and the public keys. Private keys, as the name suggests, will be kept as private, and the public key will be put in the directory. So whoever has access to the directory can collect the necessary public keys from them, and he can store in his own public key rings. So same like how Bob has a public key ring, Alice will also have a public key ring having her own friends' public keys. So next lecture series, I'll tell you in detail about how we have to encrypt with how we achieve authentication, how we achieve confidentiality using all this public key and private key, and how it is more secure compared to this symmetric encryption. I hope you all understood. Thank you.